I'm Boi Faltings, Professor of Artificial Intelligence. I came to EPFL in 1987 and started the Artificial Intelligence Laboratory as part of the new Computer Science department, which was just founded then. At that time, artificial intelligence was a very hot topic because of expert systems, computers that solved tasks that were thought to be only solvable by human experts with years of training. They are systems that choose appropriate actions to achieve specific goals that we set for them. People have very different definitions. For me, the word artificial is crucial. Artificial intelligence is different from human intelligence. It complements and extends human intelligence in situations that our brain has not been evolved to handle. For example, the work I did a long time ago in my Ph.D. thesis was about qualitative modeling of mechanical function. People have real difficulty imagining how exactly two shapes interact with one another. We have been evolved to deal with boulders maybe in a natural environment, and computers can do this much more precisely. And doing this, they can discover mechanisms that people never thought of, such as ratchets that don't need springs or gears that can only transmit motion in only one direction. Today, we find increasing complexity in planning and scheduling, and in general in coordinating many agents. Scheduling meetings in people's calendars is a simple example. Organizing a fleet of trucks to pick up and deliver packages, a more complex one. One of the first real successes of AI, in 1984 already, was scheduling the flight operations of aircraft carriers, a real headache for humans. AI solutions can be explained to and guided by humans. In my example of automated mechanism design, functions are described in a qualitative language that humans can understand. Another example is scheduling using abstractions that allow humans to understand what the crucial decisions are and why they are made in this way. AI planning systems can explain what the purpose of the different actions is, just like people do. Research in AI has always been driven by practical problems, whether real or imaginary. Throughout my career, I had to always seek collaboration with those who had problems that could use AI. Engineers, architects, airlines, telecom companies, and many more. We need descriptions of problems that should be solved with AI, we need data about specific instances, and we need evaluation of the results. This is especially so today, where almost everything involves some form of learning based on data. CIS provides me with a shortcut because other partners provide just this. We only have to plug in our solutions. One of the big challenges today is privacy-preserving AI. The most widely proposed concept is called differential privacy. But if we don't want to sacrifice the performance of AI applications, the privacy guarantees that it can provide are unacceptably loose. A researcher in my lab, Alexei Tersin, has recognized that this is because of excessive privacy protection of outliers. Where in machine learning, the influence of these outliers is reduced to regularizers, and this is not reflected in traditional differential privacy. So he has developed a new and more practical concept called Bayesian differential privacy, which obtains much more meaningful guarantees in a machine learning context. We intend to apply this concept to work in Edge AI that is initiated in CIS and hope to be the first to obtain intelligent systems with meaningful privacy guarantees. What is really dangerous is to use computers to make life and death decisions. Now, AI, as I mentioned, often provides explanations, and so it's much more suitable than black box algorithms. It's not really true for some of the modern approaches like deep learning, where people do a lot of work to integrate them into more explainable models. So AI is really part of the solution, not part of the problem.